All right, after months and months again, we're back with hydraulics. So part 2, let's jump into it. All right, so first question. An 8-inch diameter pipeline has an elevation of 150 feet with a flow of 4 cubic feet per second. What is the total energy in the pipe if the pressure is 15 psi? So here we want the total energy, which we can use the Bernoulli equation to find. Let me write that down. All right, so if we remember, this equation contains 3 terms: the elevation head, the pressure head, and the velocity head. So let's try and break down which ones we have right now. So first, we know the elevation head, 150 feet. We know the pressure, and we don't know the velocity. So let's go ahead and find that using the continuity equation since we were given the flow. So that'll be Q equals velocity times cross-sectional area, which we can convert to velocity equals flow rate divided by cross-sectional area. So let's go ahead and solve for the velocity. So we were given a diameter of 8 inches, so we need to make sure we can convert that, or we convert that to feet. So that'll give us 11.46 feet per second. So now to convert the pressure in psi to a pressure head in feet, you got to use the conversion of 2.31 feet per psi. So I'm going to go ahead and do that. We got 15 psi times 2.31 feet per psi, which will give us 34.65 feet of pressure head. So now we have everything we need to go ahead and solve for the total energy grade line. The total energy is going to be equal to 150 feet of elevation head plus 34.65 feet of pressure head, plus we'll plug in the velocity that we just found, 11.46 feet per second, square that, divided by 2 times 32.2 feet per second squared, which will give us about 186.7 feet of total energy head. First question done. All right, so on to question 2. The flow in 1,000 feet of 6-inch PVC pipe is 3 cubic feet per second. Assuming a friction factor F of 0.05, what is the head loss for this pipeline using the Darcy-Weisbach equation? So boom, we already know which equation we want to use, and just a quick reminder that Darcy-Weisbach is for pressure flow, and also you can also use the Hayes and Williams equation, but nice that we know what equation to use right off the bat. Another reminder that friction losses due to flow in pipe are considered major losses, and minor losses are from valves and bends and entrance and exit losses. So to begin this question, let's go ahead and just write out the Darcy-Weisbach equation. All right, so we got head loss from friction equals that friction factor F times length over diameter times velocity squared over 2g. So we're given a few things here. We know the length, we know the diameter, we know that friction factor, but again, we don't know that velocity. So again, we can use the continuity equation to find that velocity since we have the flow. So Q equals velocity times cross-sectional area. That to velocity equals flow over cross-sectional area. All right, so if we do that, we get, whoops, not the pencil, this one. We get 15.3 feet per second. And we already have everything, so let's go ahead and plug and chug this. All right, so we got that friction factor, 0.05. Length is 1,000 feet. Diameter 6 inches or 0.5 feet. And we can plug in the velocity we just found, 15.3 feet per second. Square that. Whoops. And then 2 times 32.2 feet per second squared. So if we plug that into the calculator, we get about 23.8 feet of head loss. All right, so there you have it. 2 quick, pretty easy ones, just some review. I'm probably gonna go on for the next video, do some open channel stuff, probably get into some longer examples, try and cover some more things, but hopefully these are good reminders, and yeah, I'll see you in the next one.